most welcome to MZ Math Online. If you are joining us for the first time, do us a favor by subscribing to the channel and also turn on the notification bell so that you will not miss any of our future videos. Today we are going to continue our lessons on Surds by looking at how to add and subtract Surds. So today our topic will be addition and subtraction of Surds. Surds can be added or subtracted if they are alike. That is to say that if the surds are in the same form, then you can add them. But if they are not in the same form, you cannot add them. What do you mean by alike? Surds means alike, or surds being in the same form. For two or more surds to be in the same form, the number inside the roots must be the same. As for the number outside the bracket, it may or may not be the same. So like surds are that surds that contain the same number in the square root. For instance, 3 root 5 and 7 root 5 are surds in the same form. That means that we can add these particular surds together. But 2 root 5 and 3 root 7 are not in the same form. They are not alike, and therefore you cannot add or subtract these surds. Now, in addition of surds, if the surds are not in the basic or simplified form, we must first of all reduce them into their basic forms before we can add or subtract them. Last week, I believe we looked at how to simplify surds, or how to reduce surds into their basic forms. So that is what you apply them in order to solve set questions. So later we'll look at some examples so that you understand very well what we are trying to say here. Now, let us make some illustrations on the addition and the subtraction of surds. If you have m root z plus n root z, we can add these two surds because they are in the same form, or they are alike, because the number inside the roots are all z. So root z, root z. So that means that the surds are in the same form, and we can add them, and we can equally subtract them. To add these two surds, what you do is you add the numbers outside the root, and then you will take one of the roots. So to add this, you have m plus n root z, as if you are going to factorize the expression. What if it is subtraction? If it is subtraction, you follow the same pattern. Nothing changes. So for instance, you have m root z minus n root z, and we are going to subtract these two surds. To subtract these two surds, as I indicated in the first scenario, you simply subtract the numbers outside the roots, and then you pick one of the roots. So in this case, this one will give us m minus n, then root z. So that is how we subtract these surds. Having a look at the illustration, we are now going to pick some questions under addition and subtraction, and then we do justice to it. show how we are supposed to add and subtract them. So now let's look at some work examples. In the work examples, we asked to simplify the following. There are 5 questions, so we'll pick them one after the other. The first one, you have 3 root 5 plus 4 root 5. So as we explained earlier on, these two SARs are like SARs. They are SARs in the same form, simply because the numbers inside the roots are the same. So we can easily add these two SARs. To add the SARs, as we explained earlier, you simply add 3 to 4 and you pick one of the SARs. So in that case, we have 3 plus 4 root 5. And this will give us 3 plus 4 will give us 7. So that will be 7 root 5. So as simple as that. The answer to the question is 7 root 5. The next one, simplifying 2 root 6 minus root 6. To simplify 2 root 6 minus root 6, we will apply the same procedure by subtracting these numbers outside the roots. So 2 minus, remember that this minus root 6 actually is minus 1 root 6, but usually if it is 1, you don't normally write that particular one. So you should note that here is negative 1. So to simplify this, we'll have 2 minus 1, then root 6. So 2 minus 1 root 6. So 2 minus 1 will give us 1. So the answer is 1 root 6. But as I said earlier on, usually if it is 1, you don't write it. So the answer will just be root 6. Now example 3. We are simplifying root 8 plus root 50 plus root 2 minus 2 root 18. Now you should bear in mind that the two questions we have solved so far, in each of the two questions, the SARs were already in their simplest form, because both root 5 and root 6, there is no perfect square that will multiply by a whole number to give us 5 and 6. So that is why 3 root 5, 4 root 5, 2 root 6, and then negative 1 root 6 are all in their basic forms. For the question 3 we are coming to solve, some of them are not in their simplest form. So since they are not in their simplest form, we have to find a way of writing them in their basic forms or their simplest form. In all the SARs in this question, it is only root 2 which is in the simplest form. All the other questions are not in their simplest form. So by simplifying these SARs into their basic forms, root 8 will be the same as root of 4 multiplying 2. When you are simplifying, you have to pick a perfect square that will multiply by a whole number to give us the number in question. And 4 is a perfect square, and 4 times 2 will give us 8. Then plus root 50 can be expressed as 25 is a perfect square, and it's a factor of 50. So I have 25 multiplied by 2 plus root 2 is already in the simplest form, so we just have plus root 2 minus 2 root 18. And to simplify root 18, I multiply 9, which is a perfect square, by 2. And 9 by 2 will give us 18. After this, we can now simplify this. Now, so this one is like another way you can write this is to write it as root 4 times root 2. And root 4 will give us 2. And then we have root 2. So the answer here will be 2 root 2 plus this is root 25 times root 2. I don't want to repeat writing it. So, and root 25 will give us 5 and root 2. So 5 root 2. Then plus root 2 minus root 9 will give us 3. And that 3 we use it to multiply by this 2. That will give us 6 root 2. Root 6. Now we have been able to simplify the SARS into their basic forms. The next thing we're supposed to do is to try adding the SARS. So we are going to add the SARS. And to add the SARS, as we already explained, since all the SARS are root 2, root 2, root 2, root 2, that means that all of them are like SARS. That means we can add and subtract them. So to simply do that, we just add the numbers outside the roots, add and subtract both here is minus, and then we pick one of the root 2's. In that case, I have 2 plus 5 plus 1. Already this is 1 plus 1 minus 6. Everything root 2. Of course, they are all root 2's. Now we can now go ahead and simplify this. 2 plus 5 will give us 7. 7 plus 1 is 8. And 8 minus 6 is 2. So the answer will be 2 root 2. 2 root 2 is the answer to the question. That is how we simplify this as well. Now we move to question number 4. We are now simplifying root 27 plus root 147 minus root 75. Once again, we are going to simplify them into their basic forms. So let's do that. To simplify this, we have root 9 times 3 plus 9 times 3 will give us 27. Then plus root 147 can be written as root 49 times 3 plus 49 times 3 will give us 147 minus root 75 can also be simplified as root 25 times 3. So root 25 times 3. Now root 9 is 3. So we have 3 root 3. So 3 root 3 here plus root 49 is 7. So it will be 7 root 3. 7 root 3 minus root 25. And root 25 is 5. So that will give us 5 root 3. Alright. And from here we can simply simplify by adding and subtracting. So we have 3 plus 7 minus 5. 3 plus 7 minus 5. All in 3. And 3 plus 7 will give us 10. And 10 minus 5 will give us 5. So the answer will be 5 root 3. So 5 root 3 is the answer to the question. And that brings us to the last question. That is question number 5. In question 5, we have 4 root 500 plus 6 root 125 minus 2 root 18. So let's see how we can simplify this. Before we simplify it, please If you are yet to subscribe to the channel, do us a favor by subscribing to the channel and also turn on the notification bell. And don't also forget to like the video and share it among your friends. Thank you. Now, let's see how we can simplify this particular question as well. So we have 4 multiply now 500. We'll get a perfect square that can multiply by whole number to give us 500. And it's very clear that 100 is a perfect square and that 100 is a factor of 500. So we simply multiply 100 by 5 and that will give us 500. And we have plus 6 with 125. With 125, 25 is a perfect square and a factor of 125. So we multiply 25 by a whole number, that will give us 125. 25 multiplied by is 5, multiplied by 5 will give us 125. So we have 25 by 5, that will give us 125. Then we have 2 roots. Now 18. 9 is a perfect square, a factor of 18, and 9 by 9 by 2, I guess 9 by 2 is 18. So we have 9 times 2 here, 9 times 2. So with this, we can go ahead and simplify this as root of 100 is 10. So multiply that 10 by 4. So let me write this before 10, then 25 plus root 25 is 5. So we multiply 6 by that 5. So I have 6 multiplying 5. Then we have root 5 minus 2 and root 9 is 3. Root 2 by 3. Then root 2. This is left with 2. From here we can simplify. 4 by 10 is 40. We have 40 root 5. 40 root 5 plus 6 times 3, 6 times 5 is 30. So 30 root 5 minus 2 times 3, which is 6 root 2. Now, if you observe the SARS very well, you can see that it is only the first 2 SARS which are alike, which are in the same form. Once you have root 5 here, you have root 5 here. This one is root 2. You can only add 40 root 5 and that of 30 root 5. This one cannot be added or subtracted from any one of these because it is not alike to them. So you only work out the first 2 SARS and leave the other one just like that. So by doing so, we add 40 to 30, we have 40 plus 30, then we have root 5 minus 6 root 2. This will give us 40 plus 30 will give us 70, plus 70 root 5 minus 6 root 2. And this will be our final answer. I said that the SARS are not alike, and since they are not alike, you cannot subtract them. So we leave it as such. And that brings us to the end of today's lesson. Until we meet again next week. Bye for now. Thank you for watching our video.